Assalamualaikum and hi everyone, welcome back to my channel. On previous video, I have discussed with you on decision tree exercises. For this video, I'm gonna do an assignment from chapter 6, clustering, specifically in k-means. Before we start, don't forget to click the button subscribe, give a thumbs up, and leave a comment and share the video if it helps you. So without further ado, let's look at the assignment. It's a question assignment split to sub-questions A, B, C, and D. Okay, here is the formula of Euclidean distance. It's very simple, like a normal distance calculation. Let us begin with the question. The question, clustering is a division of data into groups of similar features given the following 8 points: A1 to 10, A2 to 5, A3 8 4, A4 5 8, A5 7 5, A6 6 4, A7 1 2, and A8 4 9, which represent the location XY of crime scene in Bukit Bintang area. Initial central point of crime scene are as follow: Pavilion A4 58, Imbi Plaza A6 64, and Lau Yat Plaza A7 12, as shown in Figure 1. So, Figure 1 shows the locations of each point in the crime scene at Bukit Bintang area. So, for question A, we have to use k-means algorithm and Euclidean distance formula to find the members of 3 cluster centers, and you are required to fill in the distance value in the blank spaces provided in table 1. Okay, so now question A, we need to calculate by using the formula of Euclidean distance. Now we gotta find the distance from cluster P to A1 by using this formula: square root 2 minus 5 square plus 10 minus 8 square, and then we will get square root of 13. After we have square root all that 13, we will get 3.606, and that is the answer. And then continue to find the distance between C cluster Q to A1 by using the formula square root 2 minus 6 square plus 10 minus 4 square, and then we'll get square root of 52, and then the answer is 7.211. Distance from cluster R to A1, square root 2 minus 1 square plus 10 minus 2 square, then we'll get square root of 65. Then we get the answer is 8.062. Okay, now by still using the same formula of distance in Euclidean, so we will find the distance of cluster P to A2 as similar to what we did at A1. So square root 2 minus 5 square plus 5 minus 8 square, then we get square root of 18. The answer is 4.243. Same goes for this. We will get 4.123, and then we get 3.162. Okay, let's make it simple by using the formula of Euclidean distance. We will get the distance from cluster P to A3 is 5. The distance from cluster Q to A3 is 2. The distance from cluster R to A3 is 7.280. And then the distance from cluster P to A4 is 0. And then we will get the distance of cluster Q to A4 is 4.13, and the distance from cluster R to A4 is 7.211. Okay, the distance between cluster P to A5 is 3.606. The distance from cluster Q to A5 is 1.414. The distance between cluster R to A5 is 6.708. The distance between cluster P to A6 is 4.13. The distance between the cluster Q to A6 is 0, and the distance of A6 cluster R to A6 is 5.385. Okay, so now the distance from cluster P to A7 is 7.211. The distance from cluster Q to A7 is 5.385. The distance from cluster R to A7 is 0. The distance from cluster P to A8 is 1.414, and the distance from cluster Q to A8 is 5.385. And lastly, the distance from cluster R to A8 is 7.616. After we found the distance mean for each cluster, let's fill in the blank table and look at the cluster tag. We have 3 from cluster P, 2 from cluster R, and 3 from cluster Q. As for question B, we need to compute the new cluster center or centroid mean for cluster P and Q and R. Question B. Compute the new cluster center, centroid mean for cluster P, Q, and R. So by using the formula of mean, we can find the mean of cluster P, which is 3.6679. Mean for cluster Q is 7 and 4.333, and mean for cluster R is 1.5, 3.5. Easy, right? Don't give up yet. Let's go to C. C. Compute the second iteration process and then fill in the distance values in the blank spaces provided in table 2. So it's quite similar, but we have to change the new centroid mean for cluster P, Q, and R. Okay, for question C, compute the second iteration process, and then we have to fill in the distance value in the blank space provided in table 2. So for distance from cluster P to A1 is 1.944. The distance from cluster Q to A1 is 7.557. The distance from cluster R to A1 is 6.519. The distance between cluster P to A2 is 4.333. The distance from cluster Q to A2 is 5.044. And then the distance for cluster R to A2 is 1.581. And then the distance from cluster P to A3 is 6.616. The distance from cluster Q to A3 is 1.054, and then lastly, the distance between cluster R to A3 is 6.519. Okay, the distance from cluster P to A4 is 1.667. The distance between cluster Q to A4 is 4.177, and then the distance from cluster R to A4 is 5.701, and then the distance from cluster P to A5 is 5.207, and then the distance from cluster Q to A5 is 0.66, and distance from cluster R to A5 is 5.701. The distance from cluster P to A6 is 5.518. The new distance centroid for from cluster Q to A6 is 1.054, and then cluster R to A6 is
4.525, and then cluster P to A7 is 7.491, and cluster Q to A7 is 6.438, and from cluster R to A7 is 1.581. The distance from cluster P to A8 is 0.33, and the distance from cluster Q to A8 is 5.548. And lastly, the distance from cluster R to A8 is 6.042.
Okay, here we go again. After we found out all the distance mean for cluster P, Q, and R, we need to fill in the blank table. Okay, D. Determine whether the iteration process should be proceeded or stopped and state your reason. Okay, so we need to repeat the calculation of the centroid mean. If it remains the same as counted in B, so the cluster is unaffected, and if so, vice versa.
Okay, for the last question, D, determine whether the iteration process should be proceeded or stopped and state the reason. So, to find whether the iteration process should be proceeded or stopped, we need to further the calculation of centroid mean. If it the same, it doesn't change, that's mean we can stop. If it's not similar or have changed, so we have to proceed the iteration process. And now we're going to do the calculation like this. Mean for CP is still the same, which we will get 3.6679, and then mean for CQ is 4.33, and then mean for CR is 1.5, 3.5. Hence, the iteration process should be stopped because it is convergence. There is no further changes from the centroid mean.
Finally, we reach at the final question. E. Based on the answer for question 1C, draw the clusters of crime scene in figure 2 as follows. And so we already have the groups of cluster tag, and now we can draw the cluster of crime scene accordingly to the cluster tag, and the answer will be like this. Okay, we finished answering all the questions from the assignments. I guess that's all for my video today. Thank you for watching, and don't forget to subscribe and like the video. Thank you.